Academic that this class. Question here says a bag of cement 50 kg rests on an inclined plane surface with which the coefficient of static friction is 0.65. Take G 9.81 meter per second square and they say calculate the biggest angle of inclination. So first, like I always do, is to draw the angle, the inclined plane. Let's say this is the inclined plane. I don't know the angle of inclination, theta. Then this is the block, 50 kg. I don't have to start teaching you inclined plane. You know that anything acting down here is the width. And this width, even this way, this is also the width, mg. So if it's acting this way on this, is at a component of width sine theta, which is the same thing as mg sine theta. So if this block wants to go this way, the movement, there's a force that goes against movement, that is friction. Friction will be going this way, which is mu mg cos theta. That means the total force will simply be the x-axis, which is this, everything here, minus friction. So if that be the case, and since we are talking about angle of inclination, we are talking about situation whereby this is not sliding. So the MA in this case, we'll find angle of inclination taking it that this balances this. So MA will be 0, so equals to 0. So that means that X should be equals to F. See what I mean? So F here will be equals to mg sine theta minus mu mg cos theta. Because the A here will be 0, this is equals to 0, equals to mg sine theta minus mu mg cos theta. This can cross over, or let's say we'll cross this over. This becomes minus mg sine theta equals to minus mu mg cos theta. This will cancel this. Even this will cancel this. So that you now have mu. Okay, we'll say first of all, we divide both sides by cos theta, the coefficient of mu. So sin theta divided by cos theta equals to mu cos theta over cos theta. So mu sin theta over cos theta is tan theta, is equals to tan theta. So theta now will be equals to, if this tan crossover, because tan inverse of mu, and mu is coefficient of friction, and it was given to us as 0.65. I'm rushing it. So that means that this will be theta equals to tan inverse of 0.65, and this is also called angle of repose. It's also called angle of inclination or angle of repose. So let's do shift tan 0.65. So theta is equals to 33.02. Theta approximately 33 degrees. So this is how you have it whenever they ask you to find angle. So let's go to the next one. The next one says calculate the force parallel to the plane. This is this one. Calculate the force parallel to the plane which can stop the bag of cement from sliding down when the angle of inclination of the plane to the horizontal is 40 degrees. So what this thing means is, let me draw this thing here. So to find when parallel, look at, see, when we talk about parallel, see what we mean. If I have this now, and I have this, and I have this, and they say here is 40 degrees, and I have here to be that 50 kg, then parallel simply means everything here. So they are asking me, they said I should calculate the force parallel to the plane which can stop the bag of cement from sliding down. So from sliding down means going down here is mg sine theta. And going up here, because if this is sliding down, friction will go in the other way, is friction mg mu mg cos theta. They did not tell us about any force here, or maybe holding it. Assuming there's a force here holding it, it will be mg sine theta, because this now will be equal to this component for it to be at equilibrium. So for this now, to prevent it from sliding down does not mean it's at equilibrium. It does not mean it's at equilibrium. You need to know that. So if that be the case, they are asking us which force do we need in order that if we put this thing now and friction is not able to do it, which force can make this thing not to go down? So it's simply gotten from doing, they did not say dragging force. Assuming they said dragging force, we now employ that formula I taught you in the first video. So it's simply F equals to x-axis minus friction. So this is the force we are finding. So F will be equals to x-axis here is the weight down that component, which is mg sine theta, minus friction is mu mg cos theta. This is how you do it. Your textbook did adding it up, which is not possible. So when sliding, that is when you're talking about sliding and not pulling up. This is how you consider this. Because assuming it's pulling up, you now consider force going up. And anyway, let's treat what we are given. So we now have F equals to M is 50. They say we should use this to be 9.8. Then sine 40 minus mu is 0.65. Then I have times 50 times 9.8. Then cos 40. So if you do this, you now have 50 times 9.8 is 490. This is 490 sine 40 minus 0.65 times 50 times 9.8. This is 318.5 cos 40. So let's do 490 sine 40. You have 314.97 minus, let's do 318.5 cos 40. You have 243.99. So F will be equals to 314.97 minus 243.99. What am I doing? I did minus. Are you okay? That is 314.97 minus 243.99. So you have 70.98. F is approximately 71 Newton. So this is your answer. This is your answer to this question. So what it means is that friction alone cannot be able to hold this thing. So we need extra force of, we need an extra force of 71 Newton that will be going up in order to keep this from sliding. That is what it means. It's not that it has been applied, but what we are finding out is just the question that can stop it. So in order for us to stop this thing from sliding, the force we need extra is 71 Newton to make it not to slide. So let's go to the next one. I had to mix this question. I had to put this question so that you get the difference. No, now in this question, this is from chapter 4, number 7 question. They say calculate the weight of the lock. This is the lock. Oh, look at. I don't understand why it's not as bright as I want it. So this is the B they are talking about, the block. So this is supposed to be weight of the block, or the root block there. Weight of the block B. necessary to keep the object A, let's say is a ball, in equilibrium. So notice, for this thing now, if I want to analyze it, let me analyze it this way. Look at what they give me. So if I want to analyze it now, it's simply the same thing as saying this is x-axis. Sorry, this is weight and it's on the x-axis. So first of all, the force will be equals to, the force here will be equals to the weight on the x-axis. Watch. To be in equilibrium, watch. To be in equilibrium, this is going to be MA, and the A here will be 0. So weight on this x-axis, and notice this way, this one now that is going this way, as it's going this way, let's say this is that B of the lock, so minus B, because see, this one wants to go this way and this one wants to go this way. Are you seeing it? So they will be going in different directions. That means they will balance when they are at equilibrium, and that's what they're asking us. So let's say this is now WX minus B. So if you check it, this will now be 0 equals to WX minus B. So to find the weight on this block B will now be the same thing as saying if WX crossover becomes minus WX equals to minus B, this will cancel this. So B now that we are finding will be equals to WX, anything sliding down on an inclined plane is giving us, this will be, the component here will be WX sine theta, or you say mg, W is weight, mg sine theta. So B will be equals to the weight on B. Let me put weight on B now. I had to use B so you understand what I'm doing. So the weight on B will simply be, did they give me any weights? Did they give me any weights? Calculate the weight of the block. That is this particular one that is here. Did they give me weight for it? Let me check where I got that question. They are supposed to give me weights. The weights. That is the mass, sorry. They're supposed to give me the mass of that block. Let's pause this. So look at it. This question. It was given to me. They gave me 30 gram. They gave me 30 gram. So this should be, this right here is 30 gram. So first of all, let's convert the mass 30 gram to kilogram. So divide by 1000, or you say multiply by 10 raised to the power minus 3. So if I divide this by 1000, so you see you have 0.03, is it not? So if I do 3 divided by 100 now, and yes, I'm correct. So M is equals to this in kilogram. So by the time you times it with 10, so I do, or 9.8, 0.03 times 10 sine the angle here is 30 degrees. So I have sine 30 degrees. This will now be, let me multiply everything, 0.03 times 10 sine 30 is 0.5 times 0.5. So you now have weight there to be 0.15 in Newton. So sine, yes, sine 30, let me be sure. Yes, so I'm correct. So this will be your answer. So I had to solve these two questions because there's a point you read and get to. These two questions now might tend to confuse you. This is just weight on this thing. But in this particular one, they're asking you the force on everything here to keep it from sliding. But this one is just this particular one that is used. What will happen here? What is the weight on this to keep it from sliding? It's different from when they ask you what are the forces acting on a particular component. So subscribe to my channel, bro.